Hi, this video is a review for lesson 10-5 for Algebra 2. Okay, so let me go ahead and share my presentation. Okay, so this is about recursion and iteration. So we have special types of sequences. Notice that every term in the oh, that's something else. Okay, so a special sequence is called Fibonacci sequence. That was in the textbook. A Fibonacci sequence is an example of a recursive sequence, okay? In a recursive sequence, each term is determined by one or more of the previous terms, okay? So in order to get the third term, you have to figure out the first and the second term, okay? That's what that means. So the formulas you have used for sequences thus far have been explicit formulas. An explicit formula gives a sub n as a function of n, such as a sub n is equal to 3n plus 1. The formula that describes a Fibonacci sequence, which is this, is a recursive formula. So notice this is a sub n minus 2 plus a sub n minus 1, which means that every term will be determined by one or more of the previous terms. So an initial term must be given in a recursive formula. So we have the recursive formulas for sequences. So that's for an arithmetic sequence, okay, and then a geometric sequence, okay. And R is the common ratio, and then for the arithmetic, the D is the common difference. Okay, so first example says to find the first 5 terms of the sequence in which, and then it gives you some information about the sequence, okay? So first thing it tells you is that the first term is equal to 8. So we need to find the second term, the third term, the fourth term, and the fifth term. It wants the first 5 terms. It already gave you the first one, okay? So the formula is a sub n plus 1 is equal to negative 3 times a sub n plus 6, okay? So, and n has to be greater than or equal to 1, okay? So we have our recursive formula right here. So we have, to find the next term, we would have a sub 1 plus 1 is equal to negative 3 times a sub 1, okay, plus 6. So that means the second term, we already got the first, but the second term is equal to negative 3 times the first term, which they told us was 8, plus 6, okay? So then we have a sub 2 equals negative 3 times 8, which is negative 24, plus 6, and negative 24 plus 6 is negative 18. Okay, so that's the second term. So now to find the third term, we would do a sub 2 plus 1, okay, because we're looking for the third term. And then that would be negative 3 times a sub 2 plus 6. So we need the previous term to figure out the next term, okay? So that would be negative 3 times a sub 2 is, we figured out, was negative 18 plus 6. So then the third term, a sub 3, is equal to negative 3 times negative 18, which is positive 54, plus 6, which is equal to 60. So now I've got the second term is negative 18, the third term is 60. So then now I want to find the fourth term. So that's a sub 3 plus 1 is equal to negative 3 times a sub 3 plus 6. So that's a sub 4. The fourth term is equal to negative 3 times a sub 3, the third term, which we figured out was 60, plus 6. So then I've got negative 3 times 60 is going to be negative 180 plus 6. So a sub 4 is equal to negative 180 plus 6 is negative 174. So then now I've got the first 3 terms. Now I need my fourth term. So that would be a sub so that was the third term was 60. Oh, sorry, yeah, the fourth term was, now I need the fifth term, the last one. Okay, so that's a sub 4 plus 1 is equal to negative 3 times a sub 4 plus 6. So that's a sub 5 is equal to negative 3 times negative 174 plus 6. So I would multiply negative 3 times negative 174, and that ends up being positive 522 plus 6. So that's 528. So my fifth term is 528. So now I have all 5 of the first 5 terms. Okay. So in order to find a recursive formula, so in the previous example, the formula was given to us. Okay, now you're going to have a problem where you have to find the recursive formula. You need to first determine the initial term, then evaluate the pattern to generate the later terms. The recursive formula that generates a sequence does not include the value of the initial term. Okay, but we need it to figure out the recursive formula. So here we've got this sequence, okay? And if we look, we can see that here the difference would be 12, here the difference is 30, so and here the difference is 75. So obviously the difference is not the same. So it's not going to be an arithmetic sequence. This is going to be a geometric sequence. Okay, so that means that we need to find the common ratio. So we've got 20 is our second term and 8 is our first term. So we would be dividing 20 by 8, which when we simplify is 5 over 2, which is 2.5. So our common ratio is 2.5. So recall this is a geometric sequence, and our formula for a geometric sequence is a sub n is equal to the common ratio times a sub n minus 1. Okay, so I just figured out the common ratio was 2.5. So I plug that in to my formula. So I have a sub n is equal to 2.5 times a sub n minus 1. And my first term is equal to 8 because that was given to me. Okay, so we do need that first term in order, if somebody, and if you have the recursive formula and you're trying to find out the next terms, you need to have the first term. You need to have at least one of the terms in order to figure out the rest. So here, in this example, it gives you the value of the third term and the common ratio. Okay, so because it gives you a common ratio, we know it's a geometric sequence. So again, our formula is going to start off as a sub n is equal to r times a sub n minus 1. Okay, so I plug in the common ratio. So a sub n equals 4 times a sub n minus 1. So that is my formula, but I also need the first term, okay? So I'm given the third term. So what I can do is plug in the third term into my recursive formula, okay? So I would plug in, my recursive formula is a sub n equals 4 times a sub n minus 1. So I'm gonna plug in, it says a sub 3 is equal to 16. So I'm going to put 16 equals 4 times a sub n, which is 3, minus 1. So I've got 16 equals 4 a sub 2, because 3 minus 1 is 2. And then I would divide both sides by 4. So 4 is equal to a sub 2, okay? Then I need to, because that's my second term, I need the first term. So I can plug that information in. to find the first term. So again, my original recursive formula was 4 times a sub n minus 1. So I plug in 4 for the value, and I have 4 times a sub n, which would be a sub 2 minus 1. So that would be 4 times a sub 1. So now this is going to be my first term. I would divide both sides by 4. So 1 is equal to a sub 1. So that means my first term is equal to 1. So now I have my recursive formula and my first term. Okay. All right. So iteration. Iteration is a process of repeatedly composing a function with itself. So consider x sub 0. The first iterate is the function of x sub 0. The second iterate is the function of x sub 0. The third iterate is like that, and so on. So iteration can be used to recursively generate a sequence. You start with the initial value of x sub 0. So if you had, and you would let x sub 1 equal to the function of x sub 0, and so on, okay? So let's look at this. So here it says to find the first 3 iterates, okay? So we need to find x1, x2, and x3 of f of x if is equal to negative 3x plus 8 for an initial value of x sub 0, okay? So recall it just told us that x sub 1 is equal to the function of x sub 0. Well, x sub 0 is 6. So I'm going to plug in 6 in for x, okay? So I have negative 3 times 6 plus 8, okay? So this would be negative 18 plus 8, and this would be negative 10. So x sub 1 is negative 10. So then I need to figure out x sub 2. And so recall that's going to be f of x sub 1. So I need the previous term here. So that means I'm going to plug in negative 10 in for x. So that would be negative 3 times negative 10 plus 8. So negative 3 times negative 10, that would be positive 30, plus 8 would be 38. So this is x sub 2, okay? And then finally, my third iterate would be x sub 3 is equal to the function of x sub 2, which I just figured out was 38. So then that would be, now I'm plugging in 38 in for x. So that's negative 3 times 38 plus 8. So negative 3 times 38 is negative 114, plus 8 is going to be negative 106. That's my third iterate, okay? So you need to find the first one in order to find the second, in order to find the third, okay? And that's all for this lesson. So if you still have any questions, please call, text, or email me or stop by my office hours, and I'll be happy to help you and answer your questions. You have a great day.